I wonder how we deal with changing energy when dealing with water.
Glad you asked that the question. When I'm not too busy playing the video games, watching TV, or making the pasta with my cousin Bertoli, or playing fantasy football, or many other things that I actually enjoy doing, I'm busy calculating energy loss in the incompressible fluids like water. Hey, I'm over here now. Came up with this crazy equation to help you with what you're looking for. It's called the Bernoulli equation. Go figure. We're gonna solve this bad boy calculating energy per unit weight. Hey, what you looking at? Hey, I got the way to solve your problem here. I'm trying to tell you. Basically what you're gonna do is you're gonna take the density divided by specific weight. Go ahead and add the elevation that the water is at, and then you're gonna go ahead and add the velocity of the water squared divided by 2 times the gravity. This is going to give you an answer in feet. Hey, I'm over here. You got an attention problem or something, buddy? Basically what we're going to do now is we're going to take the value you just calculated and set it equal to the same equation at the final stage, plus the loss is due to friction. This is because we live in the real world and not in fantasy land. Hey, it looks like you're doing a pipe problem. Well, as a matter of fact, it just so happens I got some PVC in my back pocket. Look at this bad boy. It's pretty smooth, so its roughness value is going to be pretty low.
Where did he go?
Hey, I'm still over here. What are you doing? Hey, we're just going to take this number and we're going to divide it by the pipe's diameter to get the relative roughness value. This is going to help us to go ahead and calculate the friction once we get the Reynolds number. I'll go ahead and kick this part over to my second cousins, the neighbors, mother-in-laws, the daughter's boy. He's got emotional problems and we call him Moody.
I'm in a good mood, and yes, this is a good mood. So let's beat this problem like I'm going to beat Bernoulli in our fantasy football league. We're going to need Reynolds number, and you're lucky I have him on speed dial. He says to take the pipe diameter times the velocity over the kinematic viscosity in that wretched table in the back of the book. After that, he says to do about 7 to 8 iterations to find the friction factor. 7 to 8 hours? Now I'm not in a good mood. You're going to have to talk to Darcy Weisbach to calculate the frictional losses. I'm out of here.
Hey kid, I'm Dorsey Weisbach, yeah. And basically, you're going to take my equation, which I don't know why I made it up, but anyways, you're going to take the frictional factor here that you got from Moody. The kid's got some issues. And then you multiply that by the length divided by the diameter, and then the velocity squared there divided by 2 times the gravity. I mean, it's pretty easy, but I mean, it's so easy a caveman can do it, but I mean, you don't look too smart, so you might have some issues. Alright kid, we're gonna skip this whole minor loss business, you know, just, like I said before, you don't look like the sharpest tool in the shed, so we don't want to be here all week. I got stuff to do. So let's go ahead and put all this together. Bernoulli!
What do you want? I'm busy working the waiver wire.
Oh, come on, man! We gotta get this stuff done! Get over here!
Okay, I'm coming.
We gotta put your equation back together!
Hold your horses. Like the shades, kid, I stole them from that arrogant, good-for-nothing excuse of a person. Okay, putting it all together, kid, we got our initial conditions, which is the density over the specific weight, plus the elevation, plus the velocity squared over 2 times the gravity, plus the Darcy-Weisbach's frictional losses, is equal to the final conditions, which is the same thing, only you don't have a friction on that side of the equation anymore. Only took us 6 hours to do this, one little problem. Good luck, kid. I'm going to have to set up my fantasy football lineup now.
I got it! Got the answer. Man, those guys are a bunch of crazy characters.